Imagine this. You're in your first civil engineering job interview, and they hit you with a question about construction schedules or load factors. What do you say? Interviews can be tough, but with the right preparation, you can nail them. So today, we're going to dive into 10 essential questions that every civil engineer should know. Not only will we cover the theory, but we'll also see how these concepts apply in real-world projects. Let's get started. Question 1. What is the difference between a beam and a column? Beams are horizontal structural elements that support loads and transfer them to vertical members, while columns are vertical members that support loads from beams and other structures. Beams handle bending, while columns are primarily subjected to compressive forces. Let me break it down with a practical example. Think about the beams in a bridge. They span across supports, distributing the weight of the vehicles driving on it. The columns are what hold the beams up, supporting the entire structure vertically. Let's move on to something every engineer needs to know. Question 2. Can you explain the concept of the factor of safety? The factor of safety is a design criterion that provides a safety margin in engineering calculations. It ensures that structures can support loads beyond the expected maximums, accounting for uncertainties like material variability or unexpected loads. Take a skyscraper for example. The weight of the building materials, plus wind, seismic activity, and the number of people inside all create varying loads. To ensure the building remains safe under extreme conditions, a factor of safety is applied. So even if the actual load exceeds the anticipated load, the structure won't fail. Now, let's talk about keeping projects on track. Question 3. What is the purpose of a construction schedule? A construction schedule outlines the timeline for project tasks, helping to manage time efficiently and ensure timely completion. It also ensures resource allocation, team coordination, and that materials arrive at the right time. For instance, think about building a residential complex. The schedule will ensure that excavation, foundation pouring, and framing are done in the right sequence. If one phase is delayed, it could push the entire project back, affecting budgets and deadlines. The schedule is the project's roadmap, and as an engineer, it's your job to make sure everything runs smoothly. Let's continue with something a bit more technical. Question 4. How do you calculate the volume of concrete required for a slab? The volume of concrete can be calculated using the formula. Volume equals length times width times height or thickness of the slab. This gives the total volume of concrete needed for a specific slab. Now, in real-world scenarios, calculating this volume is crucial for avoiding wastage. For example, on a high-rise project, miscalculating concrete volume means either running short on material or ordering too much, both of which can cost time and money. Getting it right ensures you're efficient and within budget. Let's move on to the next critical concept. Question 5. What are the key properties of good quality concrete? Good quality concrete should have adequate compressive strength, durability, workability, and resistance to weathering and chemical attacks. These properties ensure that the concrete can handle loads and resist environmental factors over time. In areas with extreme weather conditions, like coastal regions or areas with freeze-thaw cycles, good concrete durability is key. For example, if you're working on a bridge in a coastal city, the concrete must resist saltwater corrosion to ensure a long-lasting structure. This is why understanding concrete properties is vital. Now, let's take a look at a question that's becoming more important every day. Question 6. What is the role of a civil engineer in environmental sustainability? Civil engineers contribute to environmental sustainability by designing eco-friendly structures, managing resources efficiently, and minimizing the environmental impact of construction projects. This includes using sustainable materials, reducing energy consumption, and incorporating green technologies like rainwater harvesting systems or solar panels. For instance, engineers working on a new office building might use recycled materials, design systems to reduce energy use, or even add a green roof to reduce urban heat islands. In today's world, sustainability is no longer an option, it's a responsibility. Let's move on to a key factor in structural design. Question 7. Can you explain the term load factor in structural design? The load factor is a multiplier applied to the expected loads in structural design to account for uncertainties. It ensures that structures can handle more than the estimated loads. For example, load factors are higher in earthquake-prone areas to account for sudden dynamic loads. Imagine designing a building in a region prone to earthquakes. The load factor will ensure that the structure can bear the added forces generated by seismic activity, keeping it safe even under extreme conditions. Now, let's dig deeper into concrete again. Question 8. What is the significance of the water-cement ratio in concrete? The water-cement ratio affects the strength and durability of concrete. A lower ratio generally leads to higher strength, while a higher ratio increases workability but can reduce the overall strength and lead to durability issues like cracking over time. In hot climates, too much water in the mix can evaporate quickly, leading to cracks in the concrete. On the flip side, a mix that's too dry can be difficult to work with. Finding the right balance is essential to ensuring both strength and ease of use. Let's shift gears and talk about contracts. Question 9. What are the different types of construction contracts? Common types of construction contracts include fixed-price contracts, cost-plus contracts, time and materials contracts, and unit pricing contracts. Fixed-price contracts lock in a price, while cost-plus contracts cover costs plus a fee. Each type has different risk allocations and is used depending on the nature of the project. For example, a fixed-price contract is perfect for a residential building with well-defined specifications, but a cost-plus contract might work better for a project with unpredictable costs, like remodeling an old structure. Knowing which contract to use helps manage both risk and budget. Finally, let's talk about one of the most important topics: safety. Question 10. How do you ensure safety on a construction site? Ensuring safety involves conducting regular safety audits, providing proper training for workers, implementing safety protocols, and ensuring the use of personal protective equipment (PPE). Regular monitoring and strict enforcement of safety regulations prevent accidents and ensure a secure working environment. On a construction site, safety isn't just about following rules, it's about making sure everyone goes home safe at the end of the day. Whether it's ensuring workers wear helmets or setting up proper scaffolding, safety should always be your top priority. That wraps up our second episode of Civil Engineering Interview Q&A. Thanks for watching, and best of luck.